The objective of this video is to learn how does Kepler describe the motion of planets around the Sun. Now, based on analyzing the observation of Tycho Brahe, German astronomer Johann Kepler proposed 3 laws that summarize how planets orbit the Sun. Kepler's first law says that the path of every planet is an ellipse with the Sun located at one of the 2 foci. So here's the ellipse drawn in green. This is the path that every planet follows around the Sun, including the Earth. The Earth doesn't follow a circular orbit, it's an elliptical orbit in which the Sun is located at one of the 2 foci. Now the sum of the distances from any point P to the foci is always constant. So if you look at this distance plus that distance, those 2 distances, whatever that sum is always going to be the same. So if P changes to this position, this distance here will be shorter, but that distance will be longer. But the sum will be constant. So PF1 plus PF2 is always going to be constant. Now, a circle is a type of ellipse. A circle is an ellipse in which the 2 foci are located at the circle's center. So an orbit for a planet can be close to being circular also, and the same would apply. Now Kepler's second law says that each planet moves so that an imaginary line drawn from the Sun to the planet sweeps out equal areas in equal periods of time. So let me explain here. Imagine the planet is located right here, and it takes 30 days for the planet to go from that position to this position. So it sweeps out this shaded area. 30 days to sweep that shaded area. Well, if the planet is now on this side of the orbit, it will go from this position to that position in 30 days. So it seems to be traveling much slower. But this area right here that it sweeps is identical to that area. That's Kepler's second law. Kepler's third law says that the ratio of the squares of the periods of any 2 planets is equal to the ratio of the cubes of their mean distance to the Sun. So T is period. Period is the time for the planet to make 1 revolution around the Sun. So T1, the period of 1 planet versus the period of a second planet, so for example Jupiter versus Mars squared, is equal to the mean distance between Jupiter and Mars cubed. Now 50 years later, Isaac Newton showed how to derive Kepler's laws using his law of gravitation.